So here's a number from our customers that stopped me in my tracks. A single semiconductor fab can generate over 9,000 alarms a day. 9,000. And the people who are supposed to respond to those, they're drowning. So most of these alarms don't even need any response, actually. But every one of them currently demands attention. That's the world our customers live in. So that's what we're talking about today on the Formant podcast. Back with me again is Fin. Something very real for us right now in the product is how our AI agents are changing the way manufacturing operations can actually be responsive to this need. Not in theory, in practice. We do it every day now. Welcome, Fin.
Thanks very much for having me again, Henrik. It's good to see you.
Good to see you. So a lot of people, and even in tech, they hear manufacturing and they think of the world as pretty automated. We've gotten to go see factories as well, and it's full of robots and rooms, but the reality is quite different when you actually see how the operations work. So can you sort of describe for our listeners what operations actually look like day to day?
Yeah, totally. It's not a bunch of systems that are running together that make sense at the surface level. It's often a bunch of underlying sensors that are all reporting data. Oftentimes there's redundant sensor systems that are reporting on values that indicate to an upstream system whether or not something is good or not, right? It's okay to proceed with operation or it's not. And oftentimes those redundant sensor systems will report values that are incomprehensible in some sort of way. And making sense of all of these different bits of information, whether or not a redundant sensor is in the right value or not, or whether that's affecting upstream systems, or if that bad sensor is actually not bad, but it's being affected by downstream sensors. Putting that whole story together to be able to catch serious critical alarms before they occur and before they affect operations, it's a really challenging thing. So that's a system that we're really trying to put together.
So we say data rich, action poor. So in the context of that reality, what does that mean?
In the context of that reality, it means there is no shortage of data. All of these chip fab facilities, not to be specific with chip fab facilities, can be any sort of advanced manufacturing company who's doing either, whether it's chip fab or biomedical, right? Or any other vertical you can think of that requires a complex sort of manufacturing process. All of their sensors are starting to be digitized. They are coming from a world in which many of them were analog, meaning they required a kind of manual checks to occur throughout the day by a set of employees like on the factory floor. But now that those sensors are being digitized, we have access to all of that sensor data and systems. But just because we have access to that sensor data doesn't mean we can always make sense of it again. So that's the goal here. We're, again, data rich, action poor right now. We have all of that data. We're not really taking advantage of it. So the whole meet the moment goal here is to make us not only data rich, but also action rich.
Right. So we got this alarm fatigue burning out the people, and definitely also a lot of tribal knowledge in this environment and data siloed across systems and sites, which really means this operational model that we're staring at is fundamentally reactive. So that's what we're going to talk about today. We're going to talk about what the solution to that is. But what's interesting, I think, about the work at Formant right now is that we're not only changing things for our customers, we're changing our own workflows as well towards something way more agentic that's part of a broader movement in AI right now, just in these recent months. So I want to jump to something you shared internally where you put agents to work in your own workflow. Can you describe how agentic AI has changed how you work yourself these days to create these solutions?
Yeah, the biggest analogy I can make is that oftentimes we deal with this game of telephone. And what that means is the customer reports an issue or maybe reports a feature request. And then that gets translated to one person, maybe it's me, and then it gets kind of groomed through a product prioritization process. And then like a full week later, it ends up making it to an engineer. And by the time that's happened, maybe it's gained some resolution, but a lot of the time it's lost some of the original intent or some of the original information, maybe if it's a bug. So we're trying to kind of shift that process to be, in a way, almost even more reactive, to say, can we fix problems much closer to the source? And the source being The issue was reported by a customer. The feature request was reported by the customer. Can we try to be more collaborative in a way with that customer and get the new feature, maybe a prototype of that feature built very quickly and get it sent to them? Or maybe we can get a bug fix out same day because we're taking in their reported bug via our intercom platform where we get messages from our customers, and we send that straight into Cloud Code, which has access to our whole system and then just starts implementing the fix right away. So all of that is to say agentic AI is totally changing the way that we operate as an engineering organization. It's also making it very possible for non-engineers to get their hands a little bit dirty and start getting into the code base. And that's been a really interesting change too.
Finn, we are at this really interesting moment in time where a lot of us are becoming familiar with agentic workflows, maybe for the first time. Imagine someone had been, on away from civilization for the last 3 to 6 months, and they were a software engineer, and then you were now tasked with getting them up to speed on what's gone on in software during that period of time. What would you tell them?
It's a great question. If they had knowledge of machine learning systems, I would say the introduction to how agentic workflows work would be not that difficult to understand. But let's say they were a software engineer in the early aughts, right? And machine learning was not as commonly understood of a thing. The way that I would start by explaining it is more almost biological or more organic. Managing a set of agents is very similar in terms of the ways in which you need to describe the problem to managing managing a team of engineers, right? Because that set of AI agents or that single AI agent is going to attempt to answer your question, to solve your problem in the way that you express the intent in your message. So let's just say a bug comes in the door and a customer has reported to me that some specific feature, let's say it's our map feature, is not performing correctly. If I take the customer's report and give it directly to the agent, to let's say Claude Code, without translating it to Claude Code, the likelihood that Claude Code is going to understand exactly what's going wrong with the map module is quite low, right? And the same goes for if I were to create a Jira ticket and give that Jira ticket to an engineer. If I don't do that kind of middle step of translation, the likelihood that the engineer is going to understand what's wrong is quite low. So there's still this process of kind of translation happening. And I think that's one of the key elements of managing a team of AI agents.
So software workflows have really changed from writing code to translate some intent into something the computer can understand, to really managing a series of agents that you speak to in natural language. And now the job, as I hear you describe it, is that you plan the approach. You make sure you understand the problem so that you can instruct these agents and then they do the execution. AI, it often feels like you have these big models that are trained on all the world's information, but most contexts, certainly the physical operations of our customers, they have a lot of tribal knowledge, a lot of experienced operators that apply the logic, their experience. Tell me, so what we do with our agents is that we give them these investigation blueprints, which essentially is a way to train the agents on specific things we want them to do and specific ways they want to work. Talk us through that.
Yeah. So of course the sensors and the different hardware components, et cetera, that different advanced manufacturing companies have, they might have the same set of components, but the likelihood that they're arranged in the same way, that they operate in the same way, is close to 0% chance. And what that means is each one of our advanced manufacturing companies has a unique flow as to how they're going to resolve different issues. Let's say a specific alarm code comes in, there's a specific set of criteria and conditions that need to be evaluated and investigated to understand what's the next step of analysis that we have to do. What is the best path to resolution, right? So all of this tribal knowledge that we call it is loaded into our system when the organization is initially onboarded into our platform, and we process all of the data that they're able to give us. And that might be a bunch of sensor data from maybe the past 1 to 2 years. And it might be a bunch of information from status systems. It might be information from their ticketing systems, from their permitting systems. We take any information that they can give us, and then we process it and translate it into these things that we call blueprints. There may be one or many blueprints for an organization, depending on how many different types of alarms they have to resolve, how many different kind of resolution paths exist within their organization. But generally, these blueprints tell us all of the important tribal knowledge that we need to know anytime we do what we call an AI investigation. Again, an AI investigation is that combination of the signal, the surrounding context, and all of the different, we call them think nodes. It's all the different agentic workflows that happen during the course of an AI investigation. So again, these blueprints can be accessed during that AI investigation and give access to our agents all of that important tribal knowledge. If we were to throw all of the tribal knowledge that exists for this whole organization at once at this AI investigation, then we'd have a problem. It would be too much context. It would be a bunch of irrelevant context. And you'd run into a situation where our AI agents weren't able to make the right decision most of the time. So a big part of these blueprints is kind of coordinating off the tribal knowledge into the relevant kind of categorizations such that our AI agents can know the right tribal knowledge at the right time.
That's so interesting. I think what's so powerful about this is that the agents are essentially these procedural masters, right? They can pay a lot of attention. They can absorb a lot of information. And then by giving them this specific institutional knowledge, we specialize them at tasks. So you get this incredible operator, incredibly consistent, intelligent operator. And then you give them the specific knowledge to deal with this tsunami of alarms coming at them. And let's get into some results of this work. So we have run some proof of concepts in recent months with major semiconductor manufacturer, which is why you're hearing this language between us, because that's very top of mind for me. So they gave us a bunch of alarms to deal with what happened.
So we noticed that when we were initially doing the processing of their tribal knowledge into our system to create the blueprints, we noticed that there was a likelihood that a lot of these alarms were going to be false alarms. And what we did is we ended up taking in not only their tribal knowledge, but we took in their, we call it ground truth into our system. And the ground truth says, for these alarms that happened in the past, what was the actual outcome? Was it determined to be a real issue, which required a true resolution path, maybe a technician on site? Or was it a false alarm? Or was it what we call a shelved alarm, meaning this alarm actually went off a month and a half ago. That part has an outstanding work order for it already. We should ignore that alarm because there's already a work order for it. It's going to be replaced in 2 weeks, let's just say. So again, we processed all the ground truth into the system, and then we've built out our own evaluator flow such that we could see what did our AI investigations, if we were to run the AI investigations on all of that past data as if this pilot had already been onboarded a year and a half ago, what would have been the outcomes? How much of the time would have we got the outcome correct, and how much time would we save operators? And the reality of the situation was that more than 50% of the time, the investigations were finding that the outcome was that it was a false alarm. And for our customers, for our pilots, for our pilot customers, that means that they were spending a lot of human operator time on just looking at an alarm and saying, oh yeah, it's a false alarm, and having to mark it as such. Not only having to mark it as such, but having to actually do the hard work of looking into the alarm and seeing, has it already been marked as maybe a shelved alarm, for instance? And we've proven that we can do the work of at the very least, kind of a junior technician, and take that load off of their existing technician staff such that they can only focus on the output of our system that's saying, this is truly a new alarm. It's not a shelved alarm. It's one that we've escalated for you. You should go look at this. And now those technicians are going to be spending their time looking into the hard problems to solve, the problems that needed to be escalated to a human technician, rather than spending all of their day going through and making sure to monitor the system and marking most of these alarms as false alarms. It's taking a big support burden off of that kind of customer.
So when you talk to this customer, typically sort of a manufacturing operations leader, what resonates with them? Do they like the cost savings, the alarm reduction? Like what hits home?
I'd say what hits home more than anything else is the potential for cost savings in a big number kind of way. Because if we're saving, again, as I said, our system can at the very least operate as kind of a junior technician, but at scale across many sites, across, again, 9,000 alarms potentially on a daily basis just for one site. That might have in the past been the work of, say, 5 or 10 or maybe even 20 junior technicians, which means that we're potentially saving a ton of labor hours for our kind of manager sort of customer.
So the value is there. That makes me think about integrating it because nobody wants to rip out their existing infrastructure. What's the integration cost here?
It obviously depends on a customer to customer basis, but ultimately, as long as we have access to export or kind of on a live basis, export the events from that system and get it connected in with Formant, then the integration cost is low. It's not like we're having to replace the SCADA system. It's not like we're having to replace their existing software stack. We are fitting in with the customer's existing software stack. And honestly, we're likely making a big part of that software stack less important for them because they're having to spend less time in the software stack and focus on doing an analysis of these things, which in reality are truly false alarms. So the other thing that we've been focusing on is this on-premise concept, which is obviously important for a lot of our advanced manufacturing companies. That is another thing that we're supporting. We're also starting to support on-premise AI models, LLMs, as well as AWS Bedrock, so that if an advanced manufacturing company doesn't want to, say, send all of their data to Anthropic and the Anthropic cloud as it's being processed by a cloud model, they don't have to. They can run a local model on AWS Bedrock and get that guarantee of security, get that guarantee of information and data, their data being locked tight shut in a local data warehouse.
It's interesting, this principle that we can adapt our agent to their workflow and not the other way around. So let's zoom out. Because of our recent work with customers, we are talking a lot about semiconductor fabs here, but the problem specifically, the data rich action poor problem, that's just not unique to that industry. So what else have we seen?
Certainly not. So some other examples of what we've seen are certainly medical applications. We've seen lots of existing kind of legacy robotics applications where you've got a bunch of different types of systems fitting in with each other. There's any time you've got basically any sort of sensor which is digitized and is resulting in a system that has some sort of output. Again, whether it could be chip fabrication, it could be any sort of automotive manufacturing, it could be really any manufacturing concept. Anytime there's an output good, that's the sort of vertical where we think we can have a really big impact in.
So if someone is listening to this from one of these manufacturing operations dealing with all this alarm fatigue and wondering how to take that first step, AI might be interesting. I want to go beyond that dashboard. What's my first step?
Your first step is to really think about, even before you come to us, think about what is the problem that you have. I remember when I was working at a different startup before Formant, that I was ending my days happy if we didn't have any issues, even just that day. Of course, we would have had issues that had it happened in the past week or the past month, but that's not a sustainable model, right? So if you are ending just your single day happy because there wasn't a fire that happened that day, then you're probably the right customer for Formant, because it means that you aren't running on a kind of scalable, reliable, and stable operational flow over time, right? There could be these spikes and outages, right? And if you're not catching those spikes and outages, and if you sometimes are needing to be the fire department ready to put the fire out, you have those people that you staff to put those fires out, for example, then you are the right customer for Formant. So you can certainly come and contact us, and we can set up an initial intro meeting with you to really start to understand your problems and start to collect your tribal knowledge. And then soon after that, we'll start ingesting your data into our system, and we'll have some really great outputs for you.
Yeah. Asking yourself, are you data rich but action poor? And are you doing a lot of reactive firefighting? Sounds like a pretty good place to start. Thank you. I love that. Hey, Finn, I think we had a good conversation today, and let's get some of these AI agents out on these factory floors, huh?
Definitely. Sounds great. Let's do it.
Awesome. Thank you.
Thanks, Henrik.